Hello. In this video, I'm going to demonstrate the main features of RapiTest. I will show you testing through scripts, testing through a stream of data, and testing through spreadsheets. RapiTest is flexible and designed to support a variety of testing formats. Here, you can see the welcome page. I'm going to open Mathematics project. Mathematics is a very small application with a simple API that adds and subtracts values. The constraint on the entire system is that we are not allowed to use any arithmetic operations to implement our mathematics library itself. Everything has to be done using bitwise operations. Let's take a quick look at the script that will power our system test. We are testing the entire code of mathematics. The system test we are observing calls an add float function repeatedly with a series of inputs specified on the command line. The test parameters are held within a make file. Inside the file, I have a runtime line which specifies 1, 20, 300, 4,000, 50,000, and so on, which should produce a result of 876543221. Now I build and run the system test. This is instrumenting the code automatically. Let's take a look at what it has done. Here's what the source code of the add float function looked like before instrumentation. Now here's the code after instrumentation. Note the instrumentation points that have been added automatically. Our system test is now complete, and we are able to look at the metrics generated. By default, we show code coverage analysis, and we can use the tabs at the bottom to view various coverage metrics our tests achieved, up to MCDC. Please see our RapiCover video for more information on our code coverage. So we've looked at blind system testing. Next, let's look at how we can supplement system testing by driving unit tests with RapiTest using a script and some stream data. I created my data stream using a simple JavaScript routine that creates 10,000 individual lines of random input data. Let's look at the stream of data the JavaScript routine produced. You can see the first two numbers in each row, when added together, equal the third number. This is the same for all the rows. Here, we see the test script, stream.rts, which controls our first unit test. This is a lightweight launcher script that is going to iterate through the rows of data in our stream and use them as inputs to a floating point number. You can see, we run A and B and check the result is equal to C. If the result is equal to C, then we know the add float function has performed correctly for that line of data in the stream. Our test script is very powerful and supports a wide range of testing formats. We open our unit testing integration. Now let's run this test by clicking Build and Run. We select the streams.rts file and click OK. The test is now running. OK, the test has run. In the Unit Tests tab, I can expand the add float function under Test and drill down to see that all our add float additions failed. So we failed our test. When we re-examine our test script, we can see there is a floating point comparison. The previous test had no tolerance parameter set, so it was too strict. Let's add a tolerance so we can avoid the impact of rounding errors. Let's rerun the test with the new tolerance applied. I'm running the test now. This time, the test passes 100% of the time on 10,000 lines of stream data. RapiTest also supports spreadsheet tests. I click on Create Test to use the inbuilt spreadsheet generator for my test. Here I can set the settings for my spreadsheet test. I select the add function contained within inmath.c. Next, I select whether I want to generate stubs or not. For this test, I will not generate stubs. On opening the newly created workbook, we see a summary of what this spreadsheet does. I can add as many sheets as I like, with each sheet representing a new test. This is a pre-populated sheet called Test1 Add. In the configuration area, I can change the way my test works. I have the scope of my test, which is Add. I don't need any test locals for my system. I told the generator that I don't need any stubs, so that area is empty too. At the bottom, I have some tests where I have some input values, but I have no outputs. By inserting a row, I can add a return check and then set the two input values and expected return value. In this case, 2 plus 2 should equal 4. I can add another test to the right, with different values. For this second test, I'm going to set the values to 2 plus 2 equals 5, to intentionally create a test that should fail. I'm going to run my spreadsheet test now. I click Build and Run and select the add.xlsx spreadsheet. The test is now running. As you can see, I have a 50% pass rate this time, as one set of values passed and one failed. We can also double-click on the Excel file from here to open the spreadsheet at the point of failure. This time, I will change the second input value to 3, meaning the return value of 5 should now pass. I save the file. Now I rerun the test. This time it passes on both tests. RapiTest can be used to drive timing tests. Under the timing integration, I select Build and Run. I select my timetest.rts script base test. This time I should receive a test report that is supplemented by timing data. We can now see the new timing-related tabs are shown this time at the bottom, next to unit tests. If I open the Invocations tab, I can see that Run 3 took the longest time to execute. We can now have a look at the script that we wrote to generate these results. Our tests do an add to 0, an add to 1, an add to -1, and an add to positives which take a series of numbers. 15, 100, 2000, and so on. It runs through each one of these and it tests them all against each other. So if we look back at our unit test results, we can see that all the tests ran. Back to our timing test, let's edit the file this time, directly in RapiTest. I am adding a reference to every single bit in the value. I believe that these inputs will provide the worst possible case the function will ever have to handle. Let's rerun the test and see what effect this has on timing behavior. Whereas test 3 was previously the slowest to execute, we can see that the new test is significantly slower. RapiTest supports multi-threaded testing designed for analyzing race conditions. First, I will open my threading integration. I open my Accumulate spreadsheet test and open the Test1 add sheet where I can edit my test. Note the scope of this test is limited to the accumulate function. Let's take a look at the accumulate function. The function simply adds an increment to a global variable called accumulator. The increment is set by a number I pass to my test. Back to the spreadsheet. Here we have a multi-threaded test. The test specifies that we are going to call accumulate 1,000,000 times, adding 7 to it each time, on thread 1. In the second thread, thread 2, we are going to add 5 to it 1,000,000 times. Basic maths tell us that adding 5 to the same value 1,000,000 times should give us 5,000,000, and adding 7 to the same value 1,000,000 times should give us 7,000,000. When we add these together, we should come to a figure of 12,000,000. Let's run the test and check the result. We can see that the multi-threaded race condition test failed, with a result near the 8.7 million mark, as opposed to the 12 million expected. Here we have proven that race conditions can affect this function. Thank you for viewing this video. These are just some of the features of RapiTest. If you would like a full demonstration of RapiTest and all of its features, please contact us at inquiries@rapitasystems.com or visit rapitasystems.com/RapiTest to learn more.